Okay, welcome back. So this is going to be the next or second example of the separable differential equations. And this one's interesting because it has dy dx equals an expression that does not contain x. So how are we going to deal with that? Well, the first step is to move dx to the other side, always. So if we multiply everything by dx, that cancels here. Do the same thing over here. Okay, we'll get dy equals y plus 2 to the 3/2 times dx. So we've got dx on the right side, we got dy on the left side, but we do have an expression with the y in it on the right. Now, we don't really need to solve for y, we just need to move this expression that contains y to the left. So what we're going to do is we're simply going to divide the entire thing by y plus 2 to the 3/2. And what that'll do is it'll cancel it completely out here. It'll divide it out. And on the left side, we're going to have y plus 2 to the 3/2 as well. So let me organize myself a little bit better. I've got 1 over y plus 2 to the 3/2 times dy. And I've got nothing left over here. But when I divided this, if you divide this by y plus 2 to the 3/2 by itself, that's really just a 1 dx. So there's no variable x, but there is a constant x. Okay? So it's actually easier than the previous example. Because now we've completed step 1, we've separated the variables, and remember this would have been a 1 point just for doing this part on the AP test. And then we need to integrate both sides with respect to each variable. So we're going to take the integral here and the integral here. Well, the integral of 1, that's not going to be too bad. That's just going to be x. But on the left side, we've got a more interesting situation. So how do we take the antiderivative of this? Of this portion? Well, some of you might think, well, use substitution, but I think we can undo this in our heads. Let's take the bottom, y plus 2 to the 3/2, and let's send it upstairs. So that's going to be y plus 2 to the negative 3/2 dy. And then we're trying to take the integral here. Okay, so what we'll do now is we will add 1. And then we'll get the quantity y plus 2 to the negative 1/2. And we need to multiply by the reciprocal, and the reciprocal would be negative 2. So let me just double check. If I take the derivative of this, will I get this expression? I'm going to do that over here on the side. So I have negative 2 y plus 2 to the negative 1/2. So that'll be chain rule. Derivative of the outside, this will be positive 2 times 1/2, which is 1, times y plus 2, take away 1, that'll be negative 3/2, times the derivative of the inside, and we're lucky, that's just a 1. So I end up with y plus 2 to the negative 3/2. And it worked out nicely because the derivative of the inside is 1. So yeah, that checks. This is my antiderivative. Okay? Now, once I've found the antiderivative, remember we're not going to put the plus c here, we're going to put it on the right side. The antiderivative of the right side is actually easier, it's just x, and then we're going to put plus c. So we separated the variables, we took the integral of both sides, and now our job is going to be to find the plus c. So originally, the previous example had an initial condition of 1, 1. The initial condition for this problem is actually going to be 0, 1. So x is 0, y is 1. And we're just going to plug those right into each of the variables. So it's going to be negative 2 times negative 1 plus 2 to the negative 1/2 equal to 0 plus c. This looks a little scary, but it actually works out to just 1. So this is 2. If I send it downstairs, I end up with 1 to the 1/2. That's the same thing as the square root of 1. So I end up with negative 2 is equal to 0 plus c is c. So I've got my c, so now I can take it back and put it where it belongs. giving me, let's clean this up a little, okay? We use a different color. It's going to be negative 2 over the square root of y plus 2. And that is going to equal x minus 2. So we've separated the variables, we've taken the integral, we found the plus c. The next step is to solve for y. Well, solving for y is going to be a little bit more challenging here because it's under a square root. So I think the best thing to do is to try to get this square root out of the denominator. And I would do that by multiplying both sides by that square root. Okay, so it reduces out here. This is a binomial, so you got to put those parentheses. Okay, so we are going to go down, scroll this down a little bit. Okay, so I now have on the left side negative 2 equals x minus 2 times the square root of y plus 2. And this is where, again, students always struggle with solving for y. I'm not going to distribute this. Instead, I'm going to divide, because I don't really want that x. I'm trying to solve for y. Divide both sides by x minus 2. That gets rid of it there. It leaves us with negative 2 over x minus 2. And that equals a square root. But we all know that a square root can be canceled by simply squaring it. So we're going to square both sides. Okay. So we're going to square it. Now, negative 2 squared is just 4. X minus 2 squared, well, we're just going to leave that as x minus 2 squared. Okay, we're not going to FOIL it out. There's really no reason to just square it, leave it in that notation. This squared gave us y plus 2. Of course, now we're just going to subtract the 2 from both sides. And so y is going to be, see, y will equal 4 over the quantity x minus 2 squared, and then we're just going to subtract 2. And that's our answer. So the last step is to consider the domain. Is there a discontinuity? And it's even easier than the previous example. You can definitely see here x minus 2, you're going to have an issue at x equals 2. That's your discontinuity. So what do we do about it? Well, we need to pick sides. At 2, if you're at a number line, this is where the issue happens. We need to pick either the right or the left of that, and that all comes down to the initial condition. The initial condition is 0, negative 1. So, of course, domain is based on x value. So where does x land? X lands on the x equals 0 lands on the left side. So we need to pick the domain that contains that. So we're going to go ahead and pick negative infinity to 2, not to 0, but to 2. It goes all the way to the discontinuity, not just to the initial condition. And that would give you the full answer. It would be the equation and its domain. Again, the AP test, sometimes they don't care about the domain, and it's not a big deal. But if it states that it wants the domain, it definitely wants the domain. Either way, if it's something this easy, I would encourage you to do it even if they didn't ask for it. So that's the next example. Hope it made sense.